We had an event based in London a couple of weeks ago, and is it weeks or months?
It's about a month, something like that. Yeah, 17th. I remember, but I don't know whether it was May or April. I think it was May or June.
Yeah.
I really don't
Yeah. Time flies quickly.
remember.
So an event and we had a presentation, and towards the end I asked if anyone had any question, and then Nick said, do you mind sharing some of my work? I said, yes, why not? So Nick presented his work, which was really exciting, especially for the use case, because we were discussing Hazelcast, real-time stream processing with Kafka, and this is exact use case Nick already had, and the demo was really good and nice demo. So we had a chat afterwards and asked Nick, hey, Nick, would you like to join our Twitch live stream to talk about demo? And Nick agreed. So welcome, Nick.
Thank you very much, Fawaz. But let me tell you a little bit about that event you hosted back then. That was in London, in Excel, in that area. That's an exhibition center. And the funny thing about it is that not too many days ago, we did run a trial, things you'll see here today, which was in exactly the same location as you did that event, which is very, very, very strange, because that trial we're planning it for months, and yeah, we do the trial, and you'll see also on the map where everything is. And then when we finish, I see, Hazelcast is doing something in London. Let me check this out. And no way they're doing that event where the trial site is. That cannot happen, right? That's not a coincidence. So this is how I came. No, you came in my backyard and I found you in there. So this is how we met. Yeah, that was very exciting, actually.
So yeah, that's really nice. So I'm based in Liverpool. Where are you based, Nick?
We are in London. We are based in the London Docklands. So yeah.
Nice area. I stayed in the area and I stayed very close to the airport. So it was really like, I don't want to say like, I felt the noise all the time. So it's nice to talk about it today.
We'll talk about it today. So what we do is, yes, noise is a part of it. So we do a lot of environmental sensing, and we're gonna see a little bit what it is we are after. And noise is something which is a environmental signal, if you like, but you use noise for many reasons. And one reason we use noise is to figure out what something does. Before we met here, and before we went live, there was this little example, situation which I was in a couple of years ago. My boss called me and said, Nick, where are you? At work, right? And what are all the seagulls, right? I can hear in the background, and all these waves. Yeah. So sometimes, you know, noise is something that can tell you something about a situation, and this is how we use noise. Yes, one thing is, of course, noise as in, this is noisy, but it's mostly also about what does it mean? What does that noise mean? So what is the meaning of it?
So that's nice. So can you just give us like a little bit of your background? I noticed like the announcement had a PhD. I wasn't aware of how you have. So perhaps,
these are past silly things I did when I was younger. So no. What I started with in my career was environment machines. That's a wrong word. Virtual machines for programming languages. They're also called environment machines over there, but they have nothing to do with the environment. So virtual machines means these are the environments that take a piece of code and execute it. And this is what I've been doing for quite some time. It's in the postcode of compilers and languages and language design and these kind of things. right? But a lot of that work was about processing streams, really, because a piece of code is really just a stream of instructions, and this is what really if you like, a virtual machine is a stream processor, right? That's what your Java virtual machine is. That's what your Python virtual machine is. It's a stream processor. When I finished my PhD, me and a colleague that has built co-built this application you're going to see today, we started a company, and we were not doing a lot of compilers when we did that, but we were still tracing streams in different things, and that was financial transactions. So a couple of years forward, and we find ourselves a lot in distributed computing, where financial transactions make a lot of sense, and stream processing and this kind of things, and fraud detection, and all these things that I think Hazelcast also has an interest. And we find ourselves a lot in fault-tolerant systems. Yes, there was distributed ledgers a lot, and still a part of our lives. And we do find ourselves later in aviation doing a lot of things around for clients, tracking where planes are, and this in a very, very distributed way. But what we do as a company here is we have an interest in environmental sensing. So these are now environment machines, but not the stream processors that try to make sense of instructions of code, but these are the stream processors that try to make sense of environmental events. I think I just made it up. It's great. I love it. I'm gonna keep it. This is what we are doing.
I think this is really interesting. Yeah, I think it's very hot topic to talk about real-time stream processing. So this is a really nice broadcast today. So I'll hand it over to you now. Feel free to share your screen and start. If you have any question from the audience, I will just forward it toward the end. So anyone is watching us now, feel free to leave your question in the chat box below, and I will get it to Nick. So over to you, Nick.
Okay, so I have a little bit of a small presentation here. It's not too long. The title is Using Hazelcast, to spell it right, in Real-Time Environmental Audits. And I do have a little bit of a start there on real time, and I wasn't sure whether I should put the real time in there or not. The reason is this: when you talk about sensing, real time sometimes means something to some people and something else to other people. So I'll talk a little bit about it, but it can become nanoseconds, or it can become few seconds. So we'll see about it. And what we do here and what we have built is a proof of concept. My colleague Abu is there to take a lot of credit for it. He's not here at the moment. He's on his way to Manchester, or I think he timed it to be on his way to Manchester to leave the hard tasks to me. But what we do is, yes, we audit manned and unmanned aircraft. And at that distance, what it means is that, yes, you are a little bit away from them, but it also means something else. And the two things you want to get out of these things is, yes, figuring out where they are. Yeah, that's a problem that's generally solved. And it is tricky, of course, to do at a scale, but it's about, yeah, X, Y, Z. It's a location. Okay, you know where they are, but what you really want to know is what they do. What do they do? Okay, they land, the takeoff. These are events. The taxi. Taxi means they're on this special lane where they are about to take off, or they spray fertilizers, or they put out a fire, or they take a picture, or they make a sound. So there's many events these things do, and we want to audit them at the distance. And at the distance here means that we want to have a third-party view of what they do, so that the operators of this aircraft can also come to us as independent auditors to tell us, can you evidence some of the things that have happened there? And what do you need? What are the ingredients to make an audit like this? You just need a nice good sensor or a bundle of it with microphones and radio signal sensing and all different combination of CO2 and this and that. Then combine all these inputs in that stream of inputs you get, and then you output the signals, create reports from it, audits, and the rest of it. And as I alluded in the introductions, that sometimes you know things where they are when you know what they do. So I remember my mom always telling me, where have you been and what you can do there? So, and indeed, this proof of concept, the reason we build it is to create a basis or foundation for us to create the specialized audits. And this is where we want to do these things. And I'm going to disappoint you, but we didn't manage to get to these places because they are very, very remote. Yes, we want to do things at a distance. So I couldn't get to these places. And that's why I asked Google ChatGPT, Google Bing, no, Microsoft Bing, sorry, Microsoft Bing to create a picture for me where there's a wetland and there's a drone flying around and there's a guy holding a sensor. This is a microphone, and it did a pretty good job at it. So this is really what we plan to do. Of course, I'm not planning to sit there to do the sensing, but you do get the picture. So yes, this is the target, but we needed to do things with what we had at hand to learn to do things, learn how to work with Hazelcast and this and that. And there is the sandbox we're using because we are located close to a local airport. And many of the situations, okay, it's not a wetland. Maybe it is because it's in the middle of a dock, but it does a lot of similar things that we are after. There's things flying around, and they make some noise. They have locations and all these things. And what we do is we do have here a sensor combo. I'm not sure if you can see my mouse, Fawaz. Is my mouse visible in this?
Yeah, I can see it. Yeah.
Oh, fantastic. Okay, so we have a sensor combo, and there's something that's emitting a radio signal and something that's picking up a noise, and we have three of them, and we combine them, and there's something here processing it and spitting it out into something visual. And as you can imagine, and here's again the other coincidence. The event we met for us was do things with Kafka and Hazelcast. Yes, this is Kafka and this is Hazelcast. So that's exactly what we did. So all these guys were sending things to Kafka and Hazelcast, processing them, Hazelcast Jet to be more specific. And this sensor combo, what it looks like a little bit like this. A company called Aerotherm built them for us. But if you want to replicate the things you'll see here today, you can do these things from with off-the-shelf components. These are very high fidelity devices. You can do very similar things with smaller and readily available components. We hook this up to a laptop and then pack it in a rucksack, and there's the sensor guy walking them around. And again, yes, I didn't plan to take them to a wetland so for tests, so I had to take them around here. A little bit about the flow of things in this application. Yes, here is the sensor unit. It is a little bit similar to a Raspberry Pi or Raspberry Pi on steroids with FPGAs and all this stuff in there. And what you have here is a antenna that is picking up radio signals from the aircraft, because aircrafts, this is what they do. They do emit a signal saying, here I am, here I am, here I am. They do send that into something called ADSB. This is the type of signal. This is the type of data that do send out, some of them. Then we have here a microphone, and it's sending out things to something we call audio, of course. And of course, these things are really just Kafka topics. As simple as you can set them up. One stream goes into this here I am, XYZ data, and here is another stream that's picking up things from the microphone. There's another component in there, which is a GPS we use this for timing of things. But if you need to rebuild something similar, how precise timing you need, it's really up to you. So yes, they go to Kafka, they get here processed with Hazelcast Jet, and we spit them out into a Quarkus application. It's a Quarkus front end, backend component, and that sticks things into a persistent store and the rest of it. If you have any questions on this choice of things, I'm happy to answer why this trio combination. I'm sure there's many different ways to do it, but I loved to do this thing with Quarkus because there were a lot of libraries to support me, and very quick to get something done. Here's an example how to pick up the audio signal and stick it to the queue. So if you want to replicate something like that, you can do something very simple as in Linux. Record your microphone, create your samples, and just throw them into a server to a UDP port. And of course, what that server or that UDP port is really something that's gonna pick up that UDP port as a very simple Java program here created for this presentation. Pick it up, and what you're gonna do is you're gonna just send it over to Kafka. Kafka record, just put it in there, and when you pick it up from the other end of Kafka, you could even replay this stream and listen to it. So you can use Kafka here as basically a radio station, if you like. Very interesting. So once a stream goes into a queue, what we do is we send it to Quarkus, and this is what we have here. Yes, we boot it, and Hazelcast is picking up our configuration and how our sources and our sinks are set up, and then there's a little bit of a front end we've built to observe things, if you like. But one of the interesting things here Hazelcast does, and it took me some while to realize, is that when you boot it, it also creates here a little bit of a structure that I kept ignoring for a very long time until I discovered it recently. So you just copy paste this into what it tells you to do, copy paste it into this place, and it'll tell you a little bit how your streams are set up. There is not much exciting going on here. So there is your windows, there's your aggregation, there's your sources, and there's your sinks. Probably the most complicated of them is the combination of how we combine the radio signals with the audio signals, and there are some funny things happening in there. You may not you may notice here that there is no, I don't know if that tool would pick it up, there is no enrichment happening, which would make sense. So we do things a little bit differently. I'll go a little bit through this, and here's another one. That's our Quarkus IDE. It's telling us all about Kafka. There is an audio topic. There is a DSB topic. Everything goes in there, and then we connect our front and back end type of application to pick up the streams from Kafka. And another one here is how things then go to the front end. A very simple REST API, and you may notice that we do use event streams. So instead of simple gets from the UI, so we let the backend, if you like, drive the front end. So streams means that the backend is creating a server sent event and just streams information to the front end. So that's a little bit interesting, because you get a stream from Kafka, the jet is processing the stream, and then we throwing it again back as a stream on the front end. And once all is running, this is how it looks like. So this is footage from the trials we had a couple of weeks or 1 or 2 months ago. And what you can see here is now things on the airport. This is the location of an aircraft. These are these bars demonstrate audio and the power of it. And what we've done here is we have color coded various places in this airport, so that we know then when we look at the historical stream down there where things have been. So for instance, this here is telling us the plane has been in this gray area and descending until it hits the green area, where it touches down and then moves a little bit into the orange area and the rest of it. But the interesting thing here we do with our stream processor is that we do merge all these streams from the 3 sensors, because there were 3 sensors, as you can see in this location, into a what we call here a frequency domain representation. And the name of this is a I really forgot now, but what it shows is the frequencies that the microphone is picking up. So, and when you overlay these things, then you can start making some observations about them, about what is happening. And what also you can observe is whether the microphones are picking up a lawnmower or a dog, or whether it is indeed a plane or not. So, and of course, as you mentioned, there is also something that may be interesting to some analysis, is the power of the noise. In our case, we do care about the power of the noise, purely though as an indicator of something happened. And as you can see here, there's an indicator that, okay, the plane is passing past that sensor. And the interesting thing here is that it is quite responsive, plane and noise here, going nicely in tandem. Of course, we play back and forth the video. Please do not assume that planes around us going back and forth. No, they don't do that.
I hope not.
Yeah, you see, drones do that, but not the ones that do land on airports. And I want a little bit to talk about real time and what that really means. And what I'm going to try to do, and I'm not sure if it's going to work. I'm going to run a little bit my demo here in the background, and it may work, it may not work. If it doesn't work, I apologize. It is it depends for it to work on whether anything is flying or not. So if nothing is picked up by a sensor, and because we are indoors, and these things are not meant to work indoors. But let's see. Yeah, did it work? We'll see. Come on. Yeah, okay, it does work. So again, we are indoors, and as you can see me here talking, it's really picking up my voice, and you can see here the sound pressure, if you like, and I'll show you a little bit how responsive this thing here. And this is now again the frequency domain of me talking into things. And I apologize for any harm caused. I'm gonna whistle into the microphone just to see you a little bit how noises are being picked up. So let's see. So, and as you can see, it's quite responsive. And I'll give you a little bit the setup I have here. Again, indoors, the GPS location has gone mad. This is not the real location of the microphone, but I have my laptop here on my desk. You can see this is localhost. Everything has fired up here: Hazelcast, Jet, Quarkus, and the rest of it. The Kafka server is somewhere else. I think it's in the cheapest instance I could get on Google, which is probably in the US. So my microphone, which sits next to my desk, is sending the signal to the US. This application here on my desktop is connecting to that Kafka source over there, and still, you know, doing all this crazy round trip. It's pretty responsive, and I'm not gonna whistle anymore, but this is something that is not too difficult to replicate. What is a little bit difficult though to do is, and again, we do not have. Let me do this. Let me just stop this here. Let me do this, and let me go over here. Yeah. These are the tricky parts, and by no means have we figured them out fully. But here's a little bit what was happening when you were seeing this demo. The aircraft is emitting two signals in this type of proof of concept. One is I'm here, I'm here, I'm here. A sensor, a radio is picking it up and it's pushing it into the Kafka stream. And let me remove this here, take it out of the way. And it also makes a noise, and it's picked up by a microphone. We put that into the Kafka topic in here. And what we do, yes, we do a little bit of windowing here to aggregate so that we can take an aggregate of a window so that we can calculate, for instance, the power of something or the frequency of something. So there's that. The window we use is a sliding window for this application, and of course we have here also this little pings from the aircraft telling us where things are. And what we do here with Hazelcast chat is that we respond to one of these pings, and then we take a aggregate of the noise and produce something for the location, and then also about what the shape of the sound was like for that location. And you may tell me, Nick, that's all very, very great, but there is a little bit of a problem, and the problem is time. Radio signals, the ones that airplanes emit, they do travel at the speed of light. So when the aircraft is emitting a location, I'm here, the sensor is picking it up if it's in our demo here pretty quickly, because speed of flight means 1 foot per nanosecond. So these sensors were, I don't know, 200 meters apart. I wouldn't go now calculating it, but it's in the realms of nanoseconds, while the speed of sound is a little bit different. It's very slower than that, and there's also a huge difference in that the speed of sound is very variable. So when the air blows against the sound source, the speed of sound is different to when the air is coming towards you, while the radio signals that the aircraft emit, they're pretty much constant. No, that they're very constant in this medium. And again, I'm not claiming to be a signal expert, but at least these two problems I'm very well aware of. And the other problem is, and this is now something that Hazelcast helps a lot with, is that the signal down here is a very continuous signal. So it's a continuous function, if you like. So there's no pauses in it. While the signal up here, which is what the planes do, is it's not very continuous. They just emit at a rate they are set to do, and it's not a continuous stream. It's maybe twice or thrice a second, these kind of things. So how do you merge now to things like that? And again, there's no answers here, but Hazelcast Jet does help in a way that, and what we have done is, and why we haven't done much of enrichment in what seemed to be a good solution for it. And again, we are not, we are also discovering here, and we are not experts, but what we did a lot is put things into a sync, and then when events were ready for us to process, go into that sync and look up for it and pick them up again. So picking up things from this sync bucket, if you like, it was a little bit of a challenge, and there's the timing, very good precise timing to annotate events with timing. This is where it matters. And he is something, for instance, what we would like to do, right? And physically we cannot. We would like to put at least the audio stream sync, if you like. We would like to put it in front of the plane, right? But there's a little bit of a problem, because you cannot put that sync in front of the plane and the microphone after it. So you'll have to do a little bit something about time there. And this is why I had a little bit of a little star in my presentation about real time. Yes, things happen in real time in that sense, but sometimes even in real time you'll have to wait for events to make decisions, because if the sound doesn't reach you, you cannot make a real-time assumption about what is happening at the distance, and that plane is at the distance. Again, we are still in discovery mode. We're trying to figure out what the best configurations are, what the best way, what is the best ways to do things. And of course, the closer you put the sensors to the source, the better you are off. And here's another one about sound and location. And you see that the plane here is taking off, and there's two sensors opposite them, two opposite sensors. And when you can see, they seem to be quite responsive at the same time. And in the pressure graph here, you'll see that there's a little bit of a difference in when these two things pick up, and it is this little differences we need for sound to calculate a little bit for how far things are apart, so that we can overlay, if you like. And here's another one that is talking about more problems. And the problem here is how do you now figure out, you can see here 3 planes doing a lot of things, or 4 actually, and which one is which. So these are all very, very interesting problems. And of course, as you can imagine, there is AI thrown at these problems, as with everything. If you can't figure out, just throw AI at it. And Hazelcast is again playing a role in this, because Hazelcast is really, really good taking something off the shelf, wrapping it up into an environment, and Hazelcast bringing up the AI environment, loading up the function, taking in the input, throwing out the output, and unloading it, and doing it again and again in quick succession, which is also what a lot of compilers do, what a lot of runtimes do. So if you go to blockchains, this is what they actually do. So that would be maybe interesting, run a blockchain with a Hazelcast. and indeed, so just to wrap it up, this is what we want to do, especially audits at a distance. Why we do that is we want to have a third-party view of what is happening. The reasons to do that is for compliance, evidence, and this kind of things. But the also very, very interesting thing to do there is what do you do if that audit at the distance is so distant where there is no internet and no power and how can you do it then offline? Oh yeah, this is the word I was looking for when I was creating this presentation. I wanted a word for not real time, and I wrote unreal time. I like that, but it's offline. Yeah, that's the word I was after. So how do you do these things offline? So how do you run Hazelcast stuff offline, of course, and of course there's again stream processing and all these kind of things, but this time the signals are taken from something else, not a Kafka source, and this is where we're taking these things. And a lot of what you've seen here is we've taken as inspiration from, I couldn't find that link. It must be somewhere. There is a Hazelcast jet telemetry demo you can find online that does this ADSB stuff already, or some of it. I can't remember it, but we took a lot of inspiration from this one. And there is another demonstration you can check out that does also a lot of things with tracking things going around, which is the IoT Edge connected car demo. Also very interesting. And yes, where we go at the moment is yes, machine learning inference is what we're gonna do next with the signals. So yes, we have all the signals, and now we're trying to characterize what does it mean. What does this picture of all these little signals mean now? Can you say things about the situation? Can you evidence things? Can you replay things? These kind of things. And again, many thanks to Abu, who is not with us. Maybe he's in Twitch. I don't know. And I'm not thanking myself. But yeah. Thank you very much, Fawaz, for having me here today.
That's great. Yeah, thank you. Thank you. Thanks very much for this cool presentation. I quite like how you can actually demonstrate it in real time. I know like real time means different things for different people, but I assume because the fact we're dealing with streaming data, and the streaming data essentially depends about latency, and like you mentioned, where is the Kafka server is located and where is the sensors are located. So it does take latency into consideration. So
Absolutely.
perhaps like, a cloud solution might be the answer in some use cases. So that's really cool. So I've got a couple of questions here for you. So first of all, the question is about the configuration you had. So could you just describe a little bit about reading the data from sensors into Kafka?
So there was a slide which you can replicate yourself. So to read to push something into Kafka, the way we've done it, and there's a slide for it, and you can copy paste that little snippet if you like. You need, for the microphone, if you want to do that yourself, is you go to your Linux, and there's a nice command in Linux that's called REC for recording things. It picks up your microphone, and what you can do is you can pipe that sound into a program, Linux program called Netcat. And what Netcat does is just really cuts things into CAT, cuts things into a IP address. So you send that thing over to that IP address, and over there's a little program picking up what you send there from the microphone. That little program is a Java program. What the Java program is the snippet in that slide. Feel free to pick that up. What it does is reading the datagrams. This is UDP, by the way. It's reading the datagrams, and whenever it gets a datagram, it says, what do I do with that? Put it into Kafka. And putting things into Kafka, as you've seen, is a one-liner. So, and you put it into a Kafka topic. Once it's in there, you have a very, very easy time with a lot of things. And if I might add to that, there is also a a possibility. There's a reason we did it with Kafka, simply because we want a replay. We want a way to replay things. But we did realize that it also makes sense to stream that little audio, if you like, straight into Hazelcast. So you can't do the same thing without Kafka. And off the top of my head, I don't remember what it's called. Is it called an iTopic or something like that? But if you don't have Kafka, or if it's just too much of configuration, I would put it straight into Hazelcast. What would eliminate a lot of the latencies there. But if there's already Kafka stuff and you cannot go away with it, yes, of course, then it makes sense.
Okay, so good. So the second question is about the enrichment. I know that you mentioned that don't have the enrichment, but the question was, do you think that it is possible to enrich this stream with the flight telemetry data or the demo from Hazelcast, where you actually have the planes and then you merge it or you enrich it for the noise levels as well? So
of course it's possible, but there is a very, very big precondition, is that you are clever enough to do it. I'm going to be very frank. We picked up Hazelcast to create this proof of concept. We learned pretty quick. We know how to enrich, but here we think we still need to do our homework to learn how to do it. Of course, it is possible. That we didn't do it was a bit of a mix of us not knowing how to do it properly and throwing things into a sink and then picking it up from there was the easy solution. And this is what we did, but it's not the best solution. The best solution would be to enrich, but I'm going to be a little bit honest, is that yes, it takes a little bit of time to learn how to talk stream processing language. So if you are not very fluent in it, it may take a little bit of time to learn how to do these things. So we are also in a learning process there. So yes, it's definitely possible. Did we do it?
Yeah. Yeah, so for anyone who is watching us now, if you go to hazelcast.com/training, so there is a tutorial and training course for stream processing where you can get going on stream processing principles, and obviously hopefully we can see more demos like Nick's ones on here. So that's cool. So the other question is, can you share your slides on our community Slack or somewhere where they can access to maybe the slides or code or whatever you can share?
I need to double check with that. I don't think there's a problem, but I still need to double check on that. So it's not
sure.
my point.
Yeah. Are you a member of our community Slack?
I am a member of your community Slack. Yes.
All right. Yeah. So for anyone watching us, we will see what we get. Essentially, the demo here is just to demonstrate how you can ingest data into Kafka and do stream processing using Hazelcast. So that's and do the visualization part, which is what is the most important part. Obviously, with the noise level, so it depends on the use case. And obviously, like you mentioned, if you have like 4 planes, which is like, other elements needs to take into consideration here. So lots of factors are going here. So this is kind of like a really cool demo and really nice use case of using Hazelcast, Jet, and Kafka for stream processing. So are there any plan for future work on this project, or what is the...
Indeed, what we plan to do is to make audits for wetlands. Wetlands are places where things are farmed or done on a wetland or a bog. And of course, it is drones that do these things because you cannot get tractors there. And what we plan to do there is we want to help the operators evidencing that they've done what they want to do, because these places are very, very remote, right? And very remote for everyone to go to check whether things are done. So and evidencing here really means a lot of things. It's did you go there and did you spray? So how do you evidence that you did spray something? Oh, okay, the nozzle makes a sound when something sprays, and you see now where sound comes into the picture. So noise as in decibels, it may be interesting for some situations, but here, what we plan to do is not really very relevant. So I don't think the birds in these places are gonna complain too much. But maybe I don't know. But this is what we try to do. We try to evidence that certain events happened when they're supposed to happen. So that's what.
Yeah, that's really nice. Like a really nice next step. So with that being said, thanks very much, Nick, for your time and for your code demo. I think that's really important to be creative, and I can see the creativity in this project. So thanks very much
Thank you
for
very
your
much.
time
Thank
and
you
for
very much.
joining us on Twitch. Anything else you want to add here?
No, thank you very much to the community as well. So I'm not very well versed in Twitch, but I'm gonna check it out.
All right. So for anyone is watching us now, we will make sure to export this from Twitch to YouTube so you can watch it as well on YouTube, and make sure to join our community Slack where you can ask questions and also contribute to our source code. So thanks, Nick, for your time, and have a good weekend. Cheers. Thank you.
Thank you, Fawaz.
Thank you.
Thanks.
Bye.